So we're going to use SAS Enterprise Guide to calculate the linear discriminant function equations using the riding lawnmower data. So we have two predictors, income and lot size, and owner or non-owner is the target. Okay. So I already have the data downloaded. So I have the data right here, the SAS data, and remember we're going to use SAS Enterprise SAS Enterprise Guide, and it works very differently from Enterprise Minor. Okay. So here you can, first thing to do is to, there is no project to create, like in SAS Minor. I'm not going to go deep into Enterprise Guide. We just will run the discriminant analysis and that would be it. Okay. So you open data. All right. So now I have the data saved here. So I'll go ahead and open that data. All right, so there's our data. Okay. Then task multivariate discriminant analysis. Okay. So now that opens up a screen that we need to populate. So the analysis variable and classification variable. Classification variable is the target. The analysis variables are the predictors. Okay. And there are lots of different options that we can select from. Okay, so we will not get into any of those. So with the variables populated, just run. And there you have the discriminant function. Okay. So what I'm going to do is just simply copy paste it. Copy that. And paste it right here. Okay. So now we have the coefficients. So as I said, it looks very much like the regression analysis equation. So here I'm going to get the discriminant function coefficients. Yes, the other one. Sorry. All right, so to make it easier for setting up the classification scores, I'm going to transpose these two functions this way. So highlight this area and then type transpose that, close parenthesis, and remember this is an array function. So Control Shift, press Control Shift and then press Enter. Now that would bring the non-owner coefficients here and owner coefficients here. So now we are ready to set up the classification scores for discriminant function, linear discriminant analysis function coefficient. So that would be, that's your constant, that's for non-owner. So that's the constant, make that absolute reference, plus we can do a sum product of these two coefficients, absolute reference that, with these two values. So that gives us the discriminant score for non-owner, right? And we do the same thing for owner, so that's the constant, plus sum product of these two coefficients, absolute reference that as well, and then the predictor values. So now we have the discriminant scores for owner and non-owner, and since this is a binary target, all we have to do is to see which one is larger and classify accordingly. So this will be like if that is greater than that, then non-owner, right? Otherwise, owner. The actual is that. Okay. Now if you want to compute propensity, that is probability of non-owner or probability of owner. So propensity for non-owner and propensity for owner. So that would be, you do e to the power of the discriminant score, all right, okay, divided by, now you e to the, you need to do the e to the power of the scores for both classes and add them up, sum of the exp values. So e to the power of non-owner plus e to the power of owner discriminant score. Okay. So now that will give us the probability of non-owner and here into F. Okay. So F39 divided by the sum, the E of F39. Of course, this is going to be 1 minus the previous one. So these are the probabilities. So if you have the probabilities, then you can set up a cutoff matrix like this. We have done this before, right? So it's count of the whole thing. Okay, so actual class of owner is count if that's your actual class is owner, so the balance will be non-owner. That's your actual class. And predicted class, again, well, if you want to change the cutoffs, then you need to do a count if This is what? Owner, right? So owner, probability of owner, okay, and then we have to say greater than or equal to ampersand that. Okay, so that will count in this range how many are greater than 0.5. So if I change this to 0.6, then go down some. If you change it to 0.3, then go up some. That one. So you're counting. This is the range to count, and this is the condition. Greater than or equal to should be within double quotation signs, and then an ampersand on the cell. Okay. So then this will be that minus that. And this, of course, you have to now look at two things. So we need count ifs. You remember we're doing this? Count ifs. Well, the owner probability, okay, that should be greater than or equal to ampersand that, right? So that will count the ones that are predicted as owner, okay, and then we need the second criteria range, which would be the actuals. The actual, okay, is owner. So predicted as owner and actual is owner. Both conditions must be true. So then rest of it would be like that. That minus that. And then this is accuracy will be that plus that divided by that, and the error rate would be 1 minus that. Sensitivity is the actual owners predicted as owners. Specificity is the actual non-owners predicted as non-owners. And false positive rate is predicted as owner but actually non-owner. False negative rate is predicted as non-owner but actually an owner. These are the different. Okay, depending upon what is critical, you would use any one of these measures or a combination of measures for the purpose of classification.